Okay, example 13 is where it gets a little bit more challenging. It's more meaningful, really, because it has real-world situation here, buying bolts. We know the total value in order of two sides of carriage bolts is 280. The smaller bolts cost 15 cents each. Larger bolts cost 25 cents each. The number of smaller bolts is 4 more than twice the number of larger ones. How many of each type are there? When you see problems that involve amount, number of things, and also value of things, as you can see, smaller bolts cost 15 cents each, larger bolts cost 25 cents each. They're giving you a value of things in the problem. The number of smaller bolts is 4 more than twice the number of larger ones. All right, so it's really important here that we create a setup that allows us to establish things about number, things about value. So the way they're specifying these two types of carriage bolts, we have a larger and a smaller bolt. I'm just going to use, I'm going to call them smaller bolt and larger bolt. They give us facts about number of bolts. They also give us facts about value of the bolts. Okay, so I'm going to create two types of things here. I'm going to have variables representing number of things and have variables representing value of things. But I can only use two variables. So it's important we get a relationship between the two. So first off, I go number first every single time. So the number of smaller bolts, number of larger bolts, that's things we don't know. How many smaller bolts, how many larger bolts, I don't know. So I'm going to use the letter S and the letter L. I'm going to use capital letters here to specify these. Lowercase l looks like a 1. I'm going to be careful when I write my S's so it doesn't look like a 5. But S and L represent the number of bolts of each type. So S could be 5, L could be 6, I don't know. But again, I'm just using variables to represent things I don't know. That's a typical algebra technique. Now, I don't know what S equals, but S is representing some number of bolts, and the smaller bolts cost 15 cents each. So, if we just try this out with real numbers, if I had one bolt, it'd be 15 cents. 2 bolts, 2 times 15, 30 cents. 3 bolts, 3 times 15, 45 cents, and so on. We take the number of bolts, whatever it is, multiplied by 15 cents to get the amount of value of the bolts. In this case, we have S bolts. The number of bolts is S. S is representing a number. So 15 times S represents the value of those bolts. Okay. This does say 15 cents, so I'm going to make sure I put a cents currency mark up there just to remind myself the value units over here represent cents. Same argument for larger bolts. Every larger bolt costs 25 cents each. We've bought L of them, and again, L is a number of bolts we bought. So take the number of bolts times 25 cents, and that's how much money we're spending on larger bolts. So for example, if L equals 4, 25 times 4 is 100 cents, which is $1. 4 bolts cost $1. If I bought 6 smaller bolts, 6 times 15 is 90 cents. So again, I'm just using this technique here to establish how much we're spending on these unknown amount of bolts. So the letter S for both smaller number and value, the letter L for both larger number and value, but the value of an individual piece goes into the value column. So then, when I start looking at my information over here as far as what they tell me, my first fact I notice is that the total value of an order is $2.80. Okay, $2.80. Now be careful, the value of currency we have in our unknowns is cents, the value over here is dollars. So I'd want to convert this into cents. $2.80 is the same as 280 cents. Every dollar is 100 cents. $1 100, $2 200, plus 80 makes 280 cents. So the total value is 280 cents, and the total value of the smaller ones is 15 S cents, and the total value of the larger ones is 25 L cents. So one equation I can make here is going to be 15S plus 25L must equal 280. 15S, how much these smaller ones are worth, plus 25L, how much the larger ones are worth, added up equals how much they're all worth, 280. Second fact given in the problem says the number of smaller bolts is 4 more than twice the number of larger ones. The number of smaller bolts, so number of smaller bolts, is equals, once again, I notice a 4 more is 4 more than. We don't care about more than or less than yet. Twice the number of larger ones. L is larger number of larger ones. And is 4 more happens after is. We're going to put a plus 4 after the equal sign at the end here. So plus 4. The number of smaller ones is 4 more than twice the number of larger ones. So just like that, we got ourselves a system of equations made up with these things. But again, this is kind of how you have to set up your unknowns when you get a number fact and a value fact. So make sure that you're going to that technique there. For me, substitution looks more efficient here. S equals, so this expression 2L plus 4 can go in place of that S. So it's going to look like this. 15. Instead of writing times S, I'm going to write times 2L plus 4. Notice I replaced one object with more than one object, so I use parentheses. Plus 25L equals 280. And now it's just a matter of solving the equation. Order of operations first. We're going to do a little distributive property here. 15 times 2L is 30L. 15 times 4 is 60. So 30L plus 60 plus 25L equals 280. Move the 60 over here now that the parentheses are gone, so we're going to get 55L if I add the two L terms together. I'm going to get 220 on this side. We divide both sides by 55. That leaves me with L equals 4. S, if I go back here, S equals 2L plus 4. But L equals 4, so S is going to equal 8 plus 4, so S equals 12. Now the other two examples, we had X and Y representing our unknowns. It didn't really matter which one was which. Now I've been more specific. L is larger, S is smaller. So it's how many of each type are there. They're specifying those types, so we need to make sure we label them properly. So I would say 4 larger bolts and 12 smaller bolts.